We're going to look at parallel and perpendicular lines. So let's get rid of that. Now let's look at these three lines. We've got y equals 2x minus 4, y equals 2x, y equals 2x plus 6. All three lines are parallel to one another. So the rule is if two lines have the same gradient, then they are parallel. Okay, so let's look some examples for this. So find the equation, like that, of a line passing through five 13 that is parallel to the line y equals 2x minus 4. So suppose the required equation is of the form y equals mx plus c. So we know that it's parallel to this one. Because they're parallel, m must equal 2. So now we've got y equals 2x plus c. Since it passes through the point 5, 13, what we can do is substitute these points into this equation. So y is 13, it must be 2 times x, which is 5, plus c. Now we've got this unknown c, so we can now rearrange the formula and solve for c. So 13 equals 10 plus c. So let's take 10 away from both sides. So that means 3 must equal c. So we've now found the equation. So y equals 2x plus 3 must be the equation for this line. Let's look at another example. We're going to look at some lines. So line number A is y equals 3x plus 5. B is y equals 2x plus 5. C is y equals x plus 5. D is x minus y equals 9. E is 2y minus 4x equals 7. Now, investigate whether any of these lines are parallel to each other. So, A and B are not parallel. You can see the m. So let's put this general formula up here. mx plus c. M here and here are different. They're not parallel. C is not parallel. to any of these. Let's look at D. D can be rewritten as y equals x minus 9. So what we've done here is we've moved the y over to here, so added y to each side, so that makes y on this side, and then we've taken 9 away from here and 9 on this side. So we've got the y as a positive and the other terms on the opposite side of the equation. Now we can see that D and C are parallel. So D and C are parallel. Now that leaves us with E. So again we're going to rearrange formula. So we're going to have 2y equals, and we're going to add 4x to each side, so 4x plus 7. And we're going to divide through by 2, so we get this y on its own. So y equals 2x plus 3.5, because 7 divided by 2 is 3.5. So this is now in a form we can deal with. So we can see that this has got 2x. B has 2x. So this is E. So B and E are parallel. When we want to compare lines, we need to put it into the standard form, and we do that by the rearranging of the formulae. Now finally we're going to think about when are two lines perpendicular. Okay, so if we have two lines, so we're going to have line y1 equals m1 x1 plus c1, and then we've got y2 equals m2 x2 plus c2, just so we can define the two different lines. If these two lines are perpendicular, if we were to take the gradient of the first line and multiply it to the gradient of the second line, we would get -1. Or we can write that as m1, so the gradient of the first line, equals -1 over m2. Just rearranged that formula. Now this is useful because we can use this to answer some questions. So I'm going to clear that away. Let's solve this. Find the equation, so let's write equation, for a line perpendicular to y equals 1/2 x plus 1, and it has to passing through 1, 4. So the gradient of y equals 1/2 x plus 1 is, we call it m1, and it equals 1/2. Now we know the perpendicular gradient, so m2 must equal -1 over m1. So that means this must be -1 over 1/2. which is 2. If you take the reciprocal of that, you end up with 2. Minus 2, sorry, because we've got the minus. So our gradient of our line must be 2, minus 2. So let's put that into a general form, into our y equals mx plus c. So we know m, y equals minus 2x plus c. Now just as before, we know it passes through this point. So let's put in the values of x and y. So y is 4. We're going to have minus 2 times 1 plus c. Rearranging that formula, we're going to get c is equal to 6. So our formula for the second line is going to be y equals minus 2x plus 6. Hope that helps.